Over the past decades, humanity has been facing a plastic crisis. Single-use plastic products such as straws, plastic bags, and bottles have caused severe consequences for the environment, the oceans, and life on Earth. Every year, millions of tons of plastic are released into the environment. Specifically, more than 500 million plastic straws are used and discarded every day in the United States alone. These tiny straws may be small, but they have an enormous impact on the environment. So how can we reduce this problem? The solution comes from alternative materials, biodegradable straws, among which PLA straws, made from polylactic acid, a bioplastic that can fully decompose, stand out. Today we will explore in detail how PLA straws are produced and why they are considered a green solution for the future. PLA, or polylactic acid, is a type of bioplastic derived from renewable resources such as cornstarch, cassava, and sugarcane. Unlike conventional plastics made from petroleum, PLA is produced through a process of fermenting natural sugars using microorganisms, which is then refined into lactic acid and polymerized into PLA plastic. PLA is fully biodegradable under industrial composting conditions, breaking down into harmless substances like CO2, water, and organic biomass. The advantages of PLA go beyond biodegradability. It is also safe for human health. PLA contains no BPA or other toxic chemicals commonly found in traditional plastics. With its transparent appearance, high durability, easy moldability, and especially its ability to last longer in water compared to paper-based products, PLA is increasingly used in various applications, especially in straw manufacturing. The PLA pellets used for straw production are supplied to the factory in prepackaged bags. These pellets have already met specific quality standards to ensure that the straws produced are free from air bubbles or cracks, while also meeting the required flexibility and color specifications. The PLA pellets are directly fed into the hopper of the single-screw extruder, the core equipment in the straw production process. Below the hopper is a screw that functions to transport, compress, and push the material through heating zones. Here, the PLA gradually melts along the screw at temperatures ranging from 180 to 210 degrees Celsius, forming a smooth and flexible molten flow. The screw rotates at a speed of 50 to 90 revolutions per minute, creating pressure that forces the material through a heat-resistant steel die, shaping hollow straws with precise diameter and wall thickness. After extrusion, the hot straws are passed through a cooling system with cold water. This cooling system includes two tanks with different temperatures. The first tank maintains a temperature of about 40 to 50 degrees Celsius to gradually lower the heat. The second tank, set at 25 to 30 degrees Celsius, completes the shaping process. So why don't we use just one tank with lower temperatures to save water and shorten the process? Because if the temperature difference between the cooling water and the hot straw is too large, the straws may experience thermal shock, causing them to bend, crack, break, or become deformed. The water inside the cooling tanks is extremely clean enough that we could even drink it. So consumers can be assured that the straws are safe to use without needing to be washed beforehand. Right after cooling, the straws pass through a vacuum calibrating machine to ensure their diameter remains consistent and perfectly shaped without deformation. After cooling, the straws are pulled through a system of rollers in the pulling machine, ensuring a stable speed synchronized with the extruder. Next, an automatic cutting machine with optical sensors precisely cuts each straw to the standard lengths of 19 centimeters or 21 centimeters. The cutting machine uses sharp alloy blades to ensure clean cuts without crushing or deforming the straws. After cutting, the straws are transferred to a rounding machine if the product requires it. This step helps enhance safety during use, especially for children. Next, the straws are inspected by an AI-powered camera system that automatically detects defects such as cracks, breaks, deformations, or incorrect sizes. Products that meet the quality standards then move on to the UV sterilization stage, ensuring food safety and hygiene before packaging. Finally, the straws are sent to an automatic packaging machine, Depending on the requirements, the straws can be individually wrapped in biodegradable paper or packed in boxes containing 50 to 100 pieces. All packaging materials are made from recycled materials to ensure environmental friendliness. Each finished product is printed with a QR code for traceability, providing transparency in the production process. PLA straws can fully decompose under industrial composting conditions within 3 to 6 months. During decomposition, PLA breaks down into water, CO2, and organic biomass, causing no harm to the environment. Unlike conventional plastics, PLA does not create microplastics and does not pose a threat to the oceans or marine ecosystems. This is a practical solution to reduce plastic waste and protect water resources. In addition to environmental benefits, using PLA straws also helps reduce the burden on urban waste treatment systems, minimizing the need for landfill or incineration that can be harmful to human health. Although the production cost of PLA straws may be 20 to 30% higher than that of conventional plastic straws, the long-term environmental and economic benefits are much greater. Many countries have implemented high environmental taxes on single-use plastic products, significantly raising the cost of plastic items. Meanwhile, governments in many regions are prioritizing support and tax reductions for businesses that use bioplastic materials. According to statistics from the European and North American markets, up to 70% of consumers are willing to pay extra for eco-friendly products, creating a huge opportunity for PLA straws. Major chains like Starbucks, Highland Coffee, and many five-star hotels have already switched to using biodegradable straws, confirming that green consumption is an inevitable trend. Moreover, when considering the costs of plastic waste management and the damages caused by environmental pollution, the hidden costs that society has to bear are far greater than the initial investment in PLA straws. This is truly an investment for the future, for a sustainable planet. Let's start making a change from the smallest things. Choosing a biodegradable straw is not only about protecting your health, but also about taking action for the environment. Join us in spreading the message, biodegradable straws, for a greener, cleaner planet. Let's take action together, starting with the smallest things. Just one biodegradable straw you choose today could save a marine creature tomorrow. Let's join hands for a greener, cleaner planet for future generations. PLA straws. A small choice, a big impact. Thank you for watching this video. If you found it helpful, don't forget to give us a like and leave a comment below. Goodbye and see you next time.